Okay, good morning to everyone. In today's lecture, basically, we will be seeing the assembly language programming in terms of 8086 processor. So today we will see the assembly language programming. Okay. So before going for programming, directly going for programming, we will first see some terms that are used uh, before we are going to use an instruction for writing a program. So we have seen different instructions. Okay. So the instructions, there are different type of instructions we have seen. So before going to start the programming by using the instructions, there are some uh, by default some steps are required before we are going to use these instructions. So that codes that we use while writing a assembly language program, that are basically called assembler directives. Assembler directives. So assembler directives basically are where there are some codes. Assembler directives are basically some codes that are uh, understandable to, I can say, assemblers or whatever we call it, linker or loader. So these are the codes that are and you can say instruction to assembler or a loader or a linker. That means uh, the, the program, whatever program we are writing, so that program will be executed by the assembler. Okay, it is assembly language program, so it will be executed by the assembler. So these assemblers should be knowing some part of the program. So it's before going for execution of program, it should be knowing like what is the code segment, what is the data segment, where the data should to be taken, and what value is the what type of data variables we have used, and what type of variables are there. So and where from where we should be starting the code segment and data segment, where it should be basically it will be assigning the segments. What is the starting location of the segments is basically. Okay. So now here in these terms, basically we will be seeing uh, some assembler directives. So one of the frequently used is called assume. Assume is an assembler directive. Basically, it is an instruction to the assembler basically that is going to compile the code. So here assembler is this assume is basically used to tell like what is the logical segment that assembler should be using for a particular specific segment. That means if we are going to uh, write this assume, then we will be providing like what segment should be going to get a particular name. Like code segment is there, so code segment will be named as code. So this code will be the logical segment, will be the logical segment used inside the code part, and that code will be used again and again instead of this code segment. Also like data segment is there, so it will be written as a data. Okay, so these are the logical segment names of the actual code segments. Okay, so this is assigned by using the assume. If assume is written, then assembler will get to know like the code segment and data segment have been assigned a logical name that will be used in the further programming. Okay, and next assembler directives part is like we will be defining the byte. It is called defined byte. So defined byte, basically what it does is it is going to define like what type of if we are using the variables, then that variable is of what type. Okay, so here uh, if we are going to define a variable, then these variables will be having a different type of data, storing a different type of data. So that will be done by defining the by using the db directive. So db against a particular variable will indicate like what type of variable it is, what type of data it will be storing. Okay, so we'll be using this db. So these are the two different directives. There are different assembly directives that we will not be going through this. Uh, we will be using only that are most frequently used in all the programs. Okay. So here there are some directives like end, and we will be using ends. Okay. So these two are the uh, different directives, similar directives. Here this end basically directs the end of the assembly language program. Okay, so if end is written, that means there will be a code of assembly language program will be, if end is there, that means thereafter there is no assembly code available for running for the microprocessor. So microprocessor will be knowing like from there this point there is no code to be executed. So this is called uh, end, means end of assembly language program. Okay, so here uh, it is end of assembly language programming. Okay, the next assembly language this directory is ends. So this ends basically marks the end of a particular, you can say end of a logical segment. Okay, so here the logical segments are basically assigned with the name uh, this called assume. So assume, if we assume is there, so this will be giving you out the name of this logical segments, like how the original segment is assigned with logical segment. So basically end is going to give uh, the end of the program, and ends is basically going to give uh, the names that appears after that. That means it will be the same ends is similar to the end or only, but the only part is like it will be giving you out in that code segment part. This assume, after this assume, this ends at the end will be using after completing all the, you can say it is going to end indicate like all the programming part have been ended. So basically the programming is divided into two parts. One is code segment part, another one is data segment part. So all the programs that we'll be using is basically this program have been divided into two parts, code segment and data segment. So whenever we will be writing a program, in case of assembly language programming, the program will start like the first segment is by data segment. Okay, so we will be starting with data segment, and then we will be defining different data. Okay, once we have defined different data, there will be we will be defining the data. After that, it will be data end. Okay, so here we will be defining different variables and data, and you can say data types. So this will be assigned inside this data segment. The next part will be the code segment part. Okay, so once we have assigned this data segment, it will be indicating like data end. Okay, next will be, now we will be writing like assume. Okay, so it will be, we will be doing assume, and then we will be assigning the code segment as code segment as code, and data segment as data. These are always used as it is, so by default it is like that. So once we have written assume directives, now we will start the code segment part. So we will write like code segment, and then we will be writing the code, whatever code is there. Then we will do like code end. Okay, so here code end, and at the last we will be writing ends. Okay, so here ends, okay. So this is how we will be writing. This is the overview of writing a program. So we will be starting with the data segment. Now we will be ending the data segment part. Now we will be providing the assembler. This assume command, this is given in all programs. Okay, the same, by default it is the code. And then we will be writing the code. So here the instructions are different instructions we will be having. So code segment means all the codes will be available here. And now we will end. So this is overall end. Okay, it will be ends. Okay, so this is how the assembly language programming in terms of 8086 is done. So now we will start with the basic programming. Okay, so in the basic programming, okay, so in the basic programming we will start with addition. So first we will see uh, we call it adder. That is an 8-bit adder. Basically we will see how this 8-bit adder we can do this 8-bit addition by using this assembly language instructions, assembly language programs, basically in 8086. Okay, so to start a program, first of all we will go for, that is, the starting will be done by, we will be defining the data segment. Okay, so in the data segment, if we are going to add two 8-bit data, so it is 8-bit adder, then we will be using two different data, that is of 8-bit. Okay, so here the data in data segment we will be defining the data, whatever variables are there. So suppose first data is data 1. Suppose data 1 is the name of first data. Okay, this is a variable, and this variable is of byte. One byte is there, so this is data db, that is data byte is being assigned, and its value is 50, suppose. So the first data that we are going to add is 50. Okay, that is of 8 bit. The next data 2, that is having a data byte. Okay, it is a byte data having value 51, suppose. Okay, now whatever data we are going to use, data 1 and data 2, we are going to add, and after that we are going to save the result into sum, because this is sum we are going to add. So it will be, suppose sum is a variable that is of a data byte, but its value is not known, so we will be writing a question mark. because what will be the value we are not known to that. So that is the variables that we will be requiring while writing the program. So we need to assign these variables in the data segment part. So now this data segment part have over, so we will be writing like data ends. Okay, so this have the completed the part called data segment part. The next we will be assigning we will be using the uh, code. Okay, so we will be using the codes here. uh, One thing I think yes. So here there is a mistake. This code segment we will be starting with here. Okay, so here it should be starting code segment. Inside this code segment, this assume will be there. So inside this code segment, this assume will be coming out. Okay, hmm. So inside this code segment, so the total program will be data segment and data segment end, then code segment and code segment ends. So inside this code segment, this assume assembler will be defined. Okay, this will be inside the uh, code segment itself. So here, once we have done this data segment part, now we will be going for the code segment part. So once the data segment part have been ended, we will go with code segment. So inside this code segment, we will be writing the code for addition of two 8-bit data. Okay. So before that, we will provide assume. We are going to give the assume command with code segment as defined as code as a logical segment, and the next one is data segment that will be defined as data as the logical segment. Okay, so now we will be starting the codes. So we will write start, and then we will be writing the codes. So we are going to get two data, and after getting this two data we are going to uh, add these two data. Okay, so here first two instructions like move, we will be writing move ax comma data, and the next instruction is move, this is data segment comma ax. So here we have given data segment is assigned by a logical name data. So data will be having the address of this data segment or the value of data segment. So the first with the starting of the writing the instructions, these first two codes will be used in all the coding part. So this is basically called initialization code. So this initialization code will be used in all the programs basically. So here this is data segment that is assigned by a data logical name. So this name that is whatever location is there, this location will be stored in ax, and this ax value will be stored in data segment. So this is the first step we will be performing while writing a program. Basically here we are going to assign the data segment with its value. Okay, so this is two instructions have been used for assigning the data segment. Now we will be going for our programming part, that by for adding the two 8-bit numbers. So the first number we have data 1. So we need to, once we are going to add, it is 8-bit data. So we will be performing the addition in the lower byte of either ax or bx register. Okay, so here we are assuming like we are going to move the first data to al we are going to move. So data 1 that we have considered the first data is being moved to al register. Now we will be moving the second data into the bl register. Okay, so this is like we have taken the data, and now this data have been moved to a register, because to add the data, either we could be using that immediate instruction, or we can directly use this also. So we are moving this data to different registers, and after moving this data we will be performing the addition. Okay, so here we will be adding, so add instruction will be used, and add al comma bl, that means bl and al will be added. So this will be like, it will be adding the al and bl, and after addition it will be going to the al register. Okay, so this al register is there, and this al register content will be the result, and the result will be should be stored in some variable we have taken. So now we will be moving this al value to some variable. So al move some, this addition of the two data will be stored with al content. So move some comma al, so al content will be moved to some variable. Okay, so now we have completed this programming part, but how to end the program basically. So here we will be going with the ending the program. So once we are going to move, we have stored the content and the result into here. Now we will to move to stop the program. We have to give an interrupt, and that interrupt will stop the executing. So it is int 21h. So int 21h is basically going to get the execution of the program of 8086 to stop. So basically in 8086 we basically use halt or some ef variable ef interrupt we provide. So here we will be providing interrupt that is having address that is 21h. Okay, so once we have provided, that will end the code. So now this is the code segment. Now we will write like it is uh, code ends. So code ends. Now we have to again make the if we want to end the complete programming, we have to write ends. And if we write ends, or we can write end start. So end start, because start have been started. So this start, now we are going to make end and start. That means we are going to end this start command, start variable segment that we have started. Okay, so to start the programming, we have to give this in int to one h as the interrupt, and then we have to end the code, and we have to end the start. Okay, so this is how we do the basic programming. Okay, so in the second part we will see the 16-bit addition. So into this 16-bit addition, we will be starting with data, like data segment. In this data segment we need to have two data, so data 1 and data 2. So data 1 and data 2. So this is a 16-bit data. So the directive that we will be using for the data 1, that will be of 16-bit. So it will be data, instead of byte it will be data word. Okay, similarly data 2 will be also be of 16 bits, so it will be assigned with data word. Okay, so data type is here basically a word is there. The data 1 and data 2 are words. So whatever data is there, we can take an example. So whatever data we see, so it is 0036H and 0004H. So this is the data that is of 16 bit. Okay, so after adding these two data, we will be storing the result into a variable, that is a sum. This sum will also be a data type, that will be of word, and its value is not known, so we will be giving a question mark. So now we will be stopping the data segment. So we are ending the data segment, so it will be data end. Data segment have been ended. Now we will go for code segment. Okay, so now in the code segment, the first command we will be giving is assume. Assume. After this assume, we will be writing like code segment will be named as code, and data segment will be named with respect to data. So these are the logical names of these codes, code segment and data segment. So now we will start the program. Okay, so here the first two instructions will always be the same, that is move ex comma data. So we are basically going to assign the data segment will be stored with data. So now this data segment value will be stored with the data value, whatever data value is there. So these are initialization code that we need to write. So once we have done the initialization, now we will be going to perform the addition. So we have two data, that is data 1 and data 2. So now we will be moving this data, move ax comma data 1. So data 1 has been moved to ax register pair. Now we will be moving the second data to bx. So data 2 will be moved to this. Okay, so once we have done this movement, now we will basically move. Once we have done, now we will be doing like add. It will be add ax comma bx. We will be performing this ax comma bx. So it is going to add two sections of data, and the result will be stored in ax. So once we have done the addition, now we will be going to move this ax value to the variable named move we have taken. So sorry, the sum variable name is there. So move sum comma ax. So whatever result is there, that will be stored in some variable. Okay, so once we have stored this data, now what we can do is we can go for stop the program. Okay, so that will be int 21h. Okay, so that's int 21h will be stopping the program. So now the program have been completed. So we will do now like we have to stop the code segment, and overall we have to stop. So it will be end, and after this end we will be writing start in the start. Okay, so this is how we should be moving to write different programs. So these are the basic programming of basic steps required for programming in 8086. There are some other terms, different other similar directives, that we will see once we will go with a higher part. And if you want to do this programming with the help of uh, some simulators, you can search for simulators. So assembly language simulators basically for 8086. So one of the simulator is emu 8086. You can take the help of from here also. There are different online simulators are also there. So you can just search for 8086 simulators or online simulator. This will give the basic platform where you can just write a program and execute it to get your results into the variables registers. Different registers are there. So these are the basic programming. We will see the in this chapter basically at the starting of this assembly language programming for 8086 is the sufficient. We have gone through different instructions. uh, we will practice it later. So in the next class, we will be dealing with the next unit, that is unit 4. And if any one of you have any difficulty, just you can put your queries into the comment box so that I will be taking all the queries. Okay, then thank you.